This is question 29 on problem solving from the 2018 BMAT. So we're given two dice, A and B, now where die A is numbered 0 to 5 on its faces, and the sum of each pair of opposite faces is 5, and with die B, it's numbered 2 to 7, and the sum of each pair of opposite faces is 9. Now these two are die A and die B, but we don't know which one's which. And so which of these below dice is another view of one of these? So where to begin? Well, it would be good if we could view the hidden faces on both these dice. So if we draw in the background, we can draw in the dots that we're missing. But we need to know which is which first. So how can we do this? Well, if we inspect this die, we can see that we have a 3 next to a 2, and that would make 5 in total. But we know on die A, the sum of the opposite faces is 5. And so we know there can't be a 2 opposite this 3, because there's already 2 here. So this can't be die A, therefore it must be die B. That leaves this one to be die A. So how do we fill in the rest of these faces? Well, we know what the sum of the opposite faces is for each of the dice. So for B, what will be opposite this 5? So 5 plus 4 would make 9, so let's put a 4 there at the bottom. What about opposite this 3? So 9 minus 3 is 6, so that has to be a 6 at the back there. Then what about on this remaining side? Well, it's opposite a 2, so it has to be a 7. Or however you're supposed to draw a 7 from dots on a dice. Then what about die A? What would be opposite this 5? So we know the sum of the opposite faces is 5 on this dice, so that wouldn't have any dots at all. Then opposite the 4, we'd have a 1, and opposite the 2, we'd have a 3. So now let's check each of these and see if everything matches up with what we've done here. So firstly, we have a 6, a 3, and a 2 all clustered in the same corner. Can we see that on either of these? Well, we know we don't have a 6 on die A, but on die B we have the 6, the 2, and the 3, but they go around the outside rather than being specific around one corner. So we know this isn't possible to get from this to this, so it can't be this option. What about here? So we have a 4, a 2, and a 3 all in one corner. Can we see that in either of these? Well, you can see here they go around the outside again, not in a corner. But on die B, we have the 4, the 2, and the 3 around this corner as required. Does this mean this is definitely the same dice? Well, if you look carefully, in this you can see that the 2 and the 3 are both sort of pointing towards the shared corner. But if you look up here, this is the shared corner, and neither the 3 nor the 2 are pointing towards the shared corner. So this is actually wrong. What about this third one? We have a 5, a 3, and a 1, all sharing a corner. Can we see that anywhere here? So in die A, we have the 5, 3, 1, all sharing this corner. And can we argue about the directionality like we did here? Well, actually, we don't know which way this 3 is going because we drew it ourselves. It could be like that, it could be like that. And we know a 5 and a 1 don't point towards anything in particular. So there's no reason why it can't be this. Now, how about this fourth one? So we have the 6, a 2, and a 5 all sharing one corner. Can we see that in die B? Well, yes, we have the 6 at the back, the 5 up here, and the 2 here, all sharing this corner. But are they the exact same? Well, here you can see that the 2 is pointing between the 6 and the 5 into the shared corner. But up here, the 2 is pointing away from the shared corner, and it's not pointing towards here. So again, this is wrong. Then finally, what about this? We have a 5, a 3, and a 4, all sharing a corner. Can we see that at all here? Yep, we have 5, 4, 3 here. But are they the exact same? Well, if you look at here, if we go clockwise around the shared corner, we have 3, then 4, then 5. But if we look at this shared corner, so we have to imagine we're looking back at ourselves from behind the screen, clockwise around this corner would be 3, 5, then 4. So these are slightly different, so they can't be from the same die. So our final answer is that this is the only die that can be the same as one of these. So our final answer is C.